What if the biggest failure in engineering project execution is not poor engineering, weak planning, bad contractors, delayed procurement, or even budget pressure? What if the real failure starts much earlier? What if the project begins losing value the moment the team starts solving before it is clearly defined what must be satisfied? That is the uncomfortable truth behind many capital projects, EPC jobs, industrial facilities, infrastructure programs, automation upgrades, manufacturing systems, and engineering design portfolios. Most engineering projects do not fail because people are careless. They fail because intelligent people work very hard on poorly framed value. They produce drawings, they issue specifications, they freeze layouts, they raise purchase requisitions, they evaluate vendors, they attend design reviews, they chase schedules, they close actions, they report progress. But somewhere underneath all that activity, nobody has clearly answered the most important question. What value is this project supposed to create? And how do we know the resources being consumed are justified? That is where value management enters. And let me be blunt. Value management is not cost-cutting. It is not a last-minute workshop to remove scope after the estimate has become painful. It is not a commercial trick to squeeze vendors. It is not asking engineers to do more with less while management avoids hard decisions. Value management is engineering leadership with discipline. It is the ability to connect need, function, cost, schedule, risk, quality, life cycle performance, constructability, maintainability, operability, and stakeholder expectation into one decision system. If you are a project manager, engineering manager, project execution manager, discipline lead, design authority, procurement leader, construction manager, commissioning manager, or senior decision maker, this is not optional thinking anymore. This is the difference between delivering deliverables and delivering outcomes. Most teams ask, what are we building? Value management asks, what need are we satisfying? Most teams ask, what equipment do we need? Value management asks, what function must be performed? Most teams ask, how do we reduce cost? Value management asks, which resources can be reduced without damaging required performance, reliability, safety, maintainability, or lifecycle value? That difference matters, because low cost is not automatically high value. High specification is not automatically high value. Maximum performance is not automatically high value. A technically beautiful solution that is expensive, over-designed, hard to build, hard to operate, difficult to maintain, and commercially unjustified may still be a poor value solution. At the same time, a cheaper solution that damages reliability, availability, safety, compliance, future expansion, or lifecycle cost is not value either. That is not savings. That is delayed pain. The simplest way to understand value is this. Value is the relationship between satisfaction of need and use of resources. When you increase satisfaction of need without increasing resources, you create value. When you reduce resources without reducing satisfaction of need, you create value. When you spend more but create a much larger improvement in performance, reliability, safety, operability, maintainability, or business outcome, you may still create value. But when you reduce cost and silently reduce essential function, you have not managed value. You have damaged the project. This is why engineering managers must stop confusing cost control with value management. Cost control tells you where money is being spent. Value management tells you whether that spending is justified by function. Cost control looks at line items. Value management looks at purpose. Cost control can tell you the price of a pump, a control system, a structure, valve package, a building service, or a utility system. Value management asks what function that element performs, how important that function is, what performance level is actually required, and whether another solution can perform the same function better. This is where engineering judgment becomes management judgment. One of the biggest reasons projects lose value is that teams confuse needs, functions, and solutions. A need is what the user, owner, operator, regulator, or stakeholder requires. A function is what the system must do to satisfy that need. A solution is one possible way to perform that function. Most project teams jump directly from need to solution. The process needs cooling, so the team specifies a particular heat exchanger configuration. The operator needs visibility, so the team specifies a certain control room layout or HMI screen philosophy. The facility needs safety, so the team adds layers of hardware without testing whether the risk is being reduced in the most effective way. The plant needs reliability, so the team adds redundancy without confirming the required availability target. The project needs environmental compliance, so the team specifies a known abatement system without comparing alternative functional paths. Sometimes the chosen solution is right, sometimes it is just familiar, sometimes it is copied from a previous project, sometimes it is the result of vendor influence, sometimes it is technically safe, but commercially inefficient. Sometimes it protects the designer but punishes the operator. Sometimes it satisfies the specification but fails the business case. Value management slows the team down at the exact moment where speed becomes dangerous. It asks, what function is required? What level of performance is mandatory? What is desirable but flexible? What constraints are real? What assumptions are inherited? What resources are being consumed? What alternatives exist? What happens across the full life cycle? That questioning is not bureaucracy. That is intelligent project leadership. The functional mindset is the heart of value management. You stop defining systems by what they are and start defining them by what they do. Do not say install pump. Say transfer fluid at the required flow, pressure, reliability, and safety level. Do not say provide control system. Say monitor process conditions, execute control logic, alert abnormal states, support safe shutdown, enable operator intervention, and preserve operational history. Do not say build warehouse. Say receive material, protect inventory, enable traceability, support picking, reduce handling damage, and maintain dispatch readiness. Do not say add redundancy. Say maintain service availability during defined failure conditions within acceptable recovery limits. This change in language changes the entire quality of thinking. Objects close the design space. Functions open the design space. The moment you name a solution too early, the team starts defending it. The moment you define the function clearly, the team is free to improve it. This is especially important for managers because many projects do not need more meetings. They need better decision architecture. Without value structure, meetings become negotiations between departments. Engineering defends technical completeness. Procurement defends commercial competitiveness. Construction defends buildability. Operations defends maintainability. Finance defends budget. Project controls defends schedule. The client defends expectation. Everyone is right from their own angle, and the total project can still be wrong. Value management gives the discussion a common structure. The team evaluates alternatives against agreed functions, required performance, cost, schedule, risk, life cycle impact, stakeholder need, and available flexibility. The conversation changes from whose preference wins to which option gives the highest value against the agreed objective. That is the difference between a review meeting and a management system. Now let us talk about the failure patterns, because this is where the subject becomes very real. Failure pattern number 1, the project has scope but no value objective. This happens all the time. The team has a scope document, it has a schedule, it has a budget, it has a responsibility matrix, it has deliverables, but it does not have a sharp value objective. So every discipline optimizes locally. Engineering optimizes robustness, procurement optimizes lowest evaluated price, construction optimizes field convenience, operations optimizes long-term access, finance optimizes capital discipline, project management optimizes milestone achievement. Each group is rational, but the project becomes misaligned. The corrective action is simple, but rarely done well. Define the value objective before major decisions harden. If the project objective is rapid market entry, schedule and modular execution may dominate. If the objective is long asset life, maintainability and lifecycle cost may dominate. If the objective is high availability, reliability and redundancy may dominate. If the objective is future flexibility, expandability and adaptable architecture may dominate. If the objective is strict compliance, assurance and risk reduction may dominate. The same technical solution is not equally valuable under every strategic objective. That is why value must be defined up front. Failure pattern number 2, the team cuts cost without understanding function. This is the classic trap. Management demands savings. The team removes items. The estimate improves. The project looks healthier on paper. Then the consequences appear later. Commissioning becomes harder. Maintenance access becomes poor. Operators create workarounds. Reliability drops. Spare parts increase. Energy cost rises. Field changes appear. Safety margins become uncomfortable. The apparent saving becomes life cycle loss. The corrective action is function-based cost review. Do not ask only, what does this item cost? Ask, what function does this item perform? How important is that function? What performance level is required? And is there a smarter way to perform it? This one habit can prevent many false economies. Failure pattern number 3. Specifications kill innovation. Specifications are necessary, but bad specifications become innovation blockers. When a specification tells a supplier exactly what to provide without explaining the functional need, performance criteria, and flexibility, it prevents better alternatives from emerging. The supplier stops thinking. The contractor complies. The project pays. A functional performance specification solves this problem. It defines what must be achieved, how performance will be evaluated, what level is mandatory, what level is desirable, what constraints are fixed, and where flexibility is allowed. This allows suppliers, designers, and contractors to propose better solutions without violating the project intent. You are no longer buying compliance alone. You are buying value. Failure pattern number 4. Value reviews happen too late. A late-stage value engineering workshop after design freeze is often just a cost-cutting exercise wearing a smarter name. At that stage, drawings are advanced. Procurement may be active. Stakeholders are defensive. Schedule pressure is high. Changes are disruptive. The team is no longer exploring value. It is trying to recover from earlier decisions. The corrective action is to apply value management at project gates. Use it during inception to define need. Use it during concept to compare strategies. Use it during feasibility to test viability. Use it during design development to improve cost effectiveness. Use it before procurement to improve specifications. Use it before construction to improve constructability. Use it after implementation to capture lessons. Value management is strongest before choices become expensive. Failure pattern number 5. Nobody owns the value program. In many organizations, value is everyone's responsibility, which quietly means it is nobody's responsibility. A mature organization needs clear ownership. Someone must identify study opportunities. Someone must define scopes. Someone must select teams. Someone must organize workshops. Someone must track proposals. Someone must verify implementation. Someone must measure benefits. Someone must feed lessons back into future standards and templates. Without ownership, value management becomes occasional, inconsistent, personality-driven, and easy to ignore. Now, if you are managing engineering execution, where should you start? Start where value leakage is high. Start with high-cost packages where small decisions create large financial impact. Start with systems that carry high lifecycle cost, such as utilities, rotating equipment, HVAC, automation, electrical distribution, material handling, maintenance-intensive assets, and infrastructure interfaces. Start with repeated designs where one improvement can multiply across projects. Start with specifications that have not been challenged for years. Start with packages where suppliers may offer better alternatives if you describe the function instead of dictating the solution. Start with constructability problems that repeatedly create field changes. Start with reliability issues that cause recurring downtime. Start with interfaces where responsibility is fragmented. You do not need to start everywhere. Start where improvement is visible, measurable, and implementable. A practical value management study should follow a disciplined sequence. First, define the business and project objective. Second, select the subject carefully. Third, form a multidisciplinary team. Fourth, collect real data. Fifth, identify the essential functions. Sixth, define required performance levels. Seventh, map cost to function. Eighth, generate alternative ways to perform the same function. Ninth, evaluate alternatives technically, commercially, operationally, and strategically. 10th, select proposals for implementation. 11th, validate risks and consequences. 12th, assign owners. 13th, implement. 14th, measure actual outcomes. 15th, feed the lessons back into future projects. That is not theory, that is decision discipline. And yes, you will face resistance. Engineering may say, we already reviewed this. Procurement may say, this will delay tendering. Operations may say, we cannot compromise. Management may say, we need savings now. Vendors may say, this is outside the specification. Project teams may say it is too late. The fallback is not to abandon value. The fallback is to adjust the depth of the study. If time is short, run a focused function cost review on the biggest cost drivers. If design is advanced, focus on constructability, maintainability, procurement alternatives, and implementation risk. If stakeholders disagree, return to functions and evaluation criteria. If cost pressure is severe, separate essential functions from secondary functions before deleting anything. If supplier innovation is possible, issue functional clarifications and invite value alternatives. If the organization lacks maturity, use facilitation, but keep ownership internal. Value management does not require perfect conditions. It requires disciplined adaptation. The deeper cultural point is this: a value-driven engineering organization does not reward activity for its own sake. It rewards decisions that improve outcomes. It does not treat deliverables as the final evidence of progress. A drawing can be issued and still be the wrong drawing. A specification can be complete and still be over-prescriptive. A package can be procured and still be poor lifecycle value. A system can be commissioned and still be difficult to operate. A project can be completed and still disappoint the business case. So the managerial shift must be from deliverables to outcomes. What need was satisfied? What function was performed? What resource was used? What risk was reduced? What lifecycle benefit was created? What stakeholder expectation was met? What future waste was prevented? This is the level where engineering management becomes business management. There is also a hard truth about over-engineering. Over-engineering is not always caused by engineers. Sometimes it is caused by unclear requirements. Sometimes it is caused by fear of blame. Sometimes it is caused by copied standards. Sometimes it is caused by weak governance. Sometimes it is caused by client indecision. Sometimes it is caused by leadership demanding certainty without giving decision clarity. So if you want engineers to stop over-engineering, do not just tell them to reduce cost. Give them clear functions. Give them performance levels. Give them constraints. Give them flexibility. Give them risk boundaries. Give them authority to propose alternatives. Give them protection when they challenge legacy assumptions responsibly. Over-engineering is often a symptom of unmanaged ambiguity. Value management reduces that ambiguity, but under-engineering is equally dangerous. Under-engineering happens when cost pressure becomes detached from function. It happens when managers remove scope without understanding why it exists. It happens when procurement awards lowest price without functional equivalence. It happens when schedule pressure suppresses technical review. It happens when minimum compliance is mistaken for fit-for-purpose performance. Value management protects against this too. It allows simplification but not ignorance. It allows savings but not value destruction. It allows flexibility but not uncontrolled compromise. For project execution managers, this is where the discipline becomes practical. Value management reduces late design changes because requirements are clearer upfront. It improves procurement because suppliers respond to performance needs instead of inherited assumptions. It improves construction because buildability is considered before the field becomes the battleground. It improves commissioning because functional performance is defined earlier. It improves operations handover because user needs are captured and validated. It improves cost control because cost is connected to function, not just line items. It improves schedule control because value issues are addressed before they become crisis recovery. The leadership standard should be simple. Every major project decision must defend its value. Not with "this is standard," not with "we did it last time," not with "engineering prefers it," not with "the client asked for it," not with "this is safest" when nobody has defined the risk. A decision should be able to explain the need it satisfies, the function it performs, the performance level it delivers, the resource it consumes, the risk it controls, the alternatives considered, and the reason it is the best available choice under the project objective. That is not slowing the team down. That is preventing rework, confusion, delay, and expensive regret. So here is the practical model you can take into your next project review. Ask 7 questions. What need are we satisfying? What functions must be performed? What performance levels are required? What resources are consumed? What alternatives can perform the same functions better? What risks, constraints, and lifecycle consequences must be considered? How will we measure whether value has actually improved? These 7 questions can transform design reviews, procurement reviews, constructability workshops, change boards, risk reviews, gate reviews, and management meetings. Because engineering project execution is only getting harder. Budgets are tighter, timelines are shorter, supply chains are more volatile, stakeholders are more demanding, sustainability expectations are higher, technology choices are broader, regulatory exposure is sharper, operational tolerance for poor design is lower. In this environment, managing only schedule, budget, and deliverables is not enough. You need management by value. You need teams that understand needs before solutions. You need specifications that enable performance instead of freezing old assumptions. You need cost discipline at the design stage, not after the estimate becomes painful. You need multidisciplinary teams that challenge decisions constructively. You need managers who can balance cost, functions, schedule, lifecycle performance, and stakeholder expectations with clarity. And above all, you need a culture where every major engineering decision can answer one sharp question. What value does this create, and is the resource justified? That is the discipline. That is the leadership shift. That is how engineering managers move from controlling projects to creating outcomes. And that is why value management is not a soft improvement concept. It is one of the most important execution disciplines for serious engineering leadership.